All right, today we're going to talk about writing exponential functions from a graph and a table. The instructions here say, write a function for each graph below and identify the a, b, y-intercept, asymptote, domain, and range. Much of this we already talked about yesterday. I'm just going to add to our understanding. First off, let's recognize that exponential functions are written in the form y equals a times b to the x. All right, where we already said in our notes that a represents our starting number. For graph's sake, we want to think about the y-intercept. All right, we want to think about the y-intercept when we're talking about graphs. All right. Now, when we talk about our b, we want to think about, we said common ratio, growth or decay factor. So we're going to say common ratio because we recognize that from geometric sequences. All right. All right. And we remember that asymptote, we're talking about horizontal asymptote. This is the line that the graph is approaching but never touches. And then domain and range. We know that the domain of exponential functions is always all real numbers unless there is not arrows at the end of the graph. And we recognize that the range is determined based off of our horizontal asymptotes. So this is kind of loaded questions because we're answering like 6 in 1. So let's get started. All right. For number 1 here, we're given this graph where from left to right there seems to be an increase in the graph. The first thing we're asked to do here is to find out our a. Remember, the a is the same thing as the y-intercept. So there's a connection between a and the y-intercept. It is our starting point. All right, so that's right here. Since the y is 1, our a is 1. To write our y-intercept, we just include the x value, which is 0, 1. All right, so we're done with that part. All right. Now, our b, remember, is our, in this case, growth factor or common ratio. So since we're given here that our y is 1 and our y here is 2, our y here is 4. All right, we can take our 2 divided by 1, and that gives us 2. So that's telling us our b is 2. Remembering that we already know that the exponential function is y equals a times b to the x, also known as f of x equals a times b to the x. So we write f of x equals 1 times 2 to the x. And just because our a is 1, we could really leave it as just 2 to the x. That's our exponential equation. When it comes to our asymptote, the graph seems to be approaching the x-axis here if we're going in reverse here, right? Seems like it's going to level off right here, and it will not cross this line, okay? So it's approaching but not crossing the x-axis. With that being said, our y is equal to 0 here, leaving us with an asymptote at y equals 0. Our domain, there's definitely not arrows for endpoints. So we're going to practice finding our domain and range, given that these are endpoints and not arrows at the end of the graph. So we start here for the domain. Remember, domain is dealing with x. So we start at -2, and we go till we get to, it's a little over 3. So maybe we'll say 3.25. So we write our domain from -2 to 3.25. The domain is in between those numbers. And our range, remember we said that our asymptote is y equals 0. So we start at 0 and we go all the way up until we get to 10. So there we are. All right, let's do 2. Let's do 2. All right, remember our A is the same as the y-intercept. So our A in this situation is, you got it, it's 8. But how do we write that as a y-intercept? 0, 8. All right, our B, we start here with our 8, right? That's our y for 1 point. The next point, our y is 4. The next point, our y is 2. So if we want to determine our common ratio, we take our 4 divided by 8. That leaves us with a half. So that's our B. All right, that's our B. So to write our exponential function, a times b to the x, that's 8 times a half to the x. There we are. And our asymptote, remember that's the line the graph approaches but doesn't touch. And it is the x-axis. So our asymptote is y equals 0. All right. Our domain, we really can't see where it ends, even though we can see where it begins up here. So it begins just over x equals 0, so about at -0.5. And like I said, we really can't see where it ends because it ends up going over. But because there's no arrow, we're going to say it ends right here at 10, okay? So x is in between -0.5 and 10. And our range, now since our asymptote is at y equals 0, we know that our range goes from 0 and it goes as high up as right up here where y is 10. So our range is from 0 to 10. All right. Hopefully we're understanding the difference between endpoints, right? And arrows. So like, let's say I put an arrow here and here, right? There's a difference there. All right, because if this is an arrow, we're going to treat our domain and range differently, but everything else will remain the same. So we're going to complete number 3 as if there's arrows at the end of this graph. All right, so for A, right, help me out. What does A appear to be here, right? Yep, you guessed it. 0.5. And our B, well, we start at 0.5, right? Or a half. And then we go to, we're looking at our y's of the points. All right, so 0.5 to 8. All right, so that if we divide 2 divided by 0.5, we come out with 4. So our common ratio, or B, is 4. And when we write our equation, it becomes 0.5 times 4 to the x. Now, since our a is 0.5, that means our y-intercept is 0.5, but our x is 0. And this graph is definitely approaching the x-axis, so our asymptote is y equals 0. And our domain, when there's arrows, remember, is always all real numbers. What about our range? Well, this arrow right here at the right is telling us that it's going to continue to increase. And this asymptote is telling us that it's our boundary line for the range, y equals 0. So our range starts at 0 and goes all the way up to positive infinity. So our range is y is greater than 0. All right. So I'm going to have you guys complete number 4 as if these are endpoints, right? There's an endpoint here, right? Endpoint. All right. Just kind of treat it that way. All right. So I want you to complete that. And I want you to complete 5. But I want you to treat this one as if there are arrows at the end. All right. Feel free to press pause. I'm going to move on to finding the information given a table. So number 6 and 7 should be kind of easy to us because all we're asked to find is A, B, and then to write the equation. Well, we already know that our A is the same as the y-intercept, right? And the intercept is the point where the graph crosses the y-axis, or the value of y when x is 0. We can look right here and see that our y is 0.125 and x is 0. So that's our y-intercept, 0.125. And to determine our b, our common ratio, we take this y and divide it by this, the first y. Or it doesn't have to be that way. We could take, 4.5 and divide it by 0.75. But either way we look at it, we are going to need a calculator. So here we go. .75 divided by 0.125 gives us 6. Gives us 6. So then what should our equation be? 0.125 times 6 to the x. And we're done with number 6. Number 7, right? Help me determine what our A is. Value of y. This is our y. This is our x. When x is 0, so our A in this situation is 64. Our B, we take 32 divided by 64. That's a half. So our equation is 64 times a half to the x. And now you're going to complete practice problems.